So today we are going to cover, it's a very required aspect of software engineering, where most of even senior engineers, senior engineers doing this wrong, right? They do, I have seen even a few weeks back, I was doing a code review, that's wrong, okay? So therefore, we are going to discuss that because this is a very wrong practice people do, right? So that is logging and exception handling, right? I'm not sure whether I can cover the both today, but I'm going to see how far I can go, okay? Because this looks like very simple. When come to interviews, people, when we ask the questions, they say, yeah, I know exception handling, I know the logging practices and everything. But if you go deeper, most of the time, they don't know it. They don't know it more in the sense that they don't do it properly. First, tell me why we logging in applications. Logging in the sense not log in, the logging, put the logs. Why we put the logs on application? When you develop something, why you put logs? To look at the internal process. Any other idea? To debug. To help the debug. Okay. What else? What else? Why we put the logs? Shankar, why we put the logs? You cannot manage the activities through the logs because logs just dumping something. So we logging for multiple reasons, mainly to see what is going on, right? See what's happening, and then also, as he said, debugging. So debugging is a part of this, right? So debug, you need to see what's happening, right? But the problem is this: we need to understand this logging, if you not do properly, it create huge vulnerabilities. For example, let's assume you are working on inventory management system or a invoicing system, right? So every invoice you raise in the system, for a debugging purpose, you log, right? And also, let's say you buy items. So you log in the GRN cost, because there is an object when the GRN comes, good receive notes, GRN in the sense, you put a purchase order, right, to your supplier. Let's say you are running a store, right, you are running out of markers. So you put a purchase order to the Atlas saying, I need this much of markers, this many, I need 1,000 box. So when they send the 1,000 box, you put in the system. When you put in the system, especially when you put the purchase order as well as the GRN, you put the price. So now the price is there. Okay. So now when you invoice, sometimes you put that as a log. Right? This invoice, this. Now the problem is this. So now if you put the purchase order in the system or an invoice on the system, where this goes? End of the day? To the database. This goes to database. Now this database is very protected. Right? This database is very protected. Probably we put this into a private subnet. Right? We don't even put public subnet, and a very restrictive access control, right? So only, like, there are so many processes, like like you guys know it, but here when we get the, if someone need access to even a UAD database, and you need to get multiple access control process. You need to first tell your lead you need this access, then he need to approve, then it go to the manager, then PM, he need to approve, then it come to me, then I need to approve, then only it go to the database team and they give the access to you. Right? Why? Because we want to protect the data, because data is the key thing in the system. Now, you put those in a logs. Logs are we not protecting like that. Logs are just a files, right? Logs are just a files. So they, for example, for us, we are shipping the logs to right now to third-party company, third-party tool, right? It is not even in our cloud. The logs go to different vendors' cloud. I understand we have NDAs, non-disclosure agreement, saying they are not processing our own data, but who knows? Technically possible. Not doing is something else, but it is possible, right? So that is a danger we are facing. let's say we are not pushing to some other cloud. Still we are storing somewhere. Let's say you are not on a cloud native, right? You are on on-prem. You are putting in a bunch of storages, right? So now admin team or infrastructure team also think, these are logs, it's fine, right? The logs are usually by nature not treating sensitively, right? So when it say, okay, this is a log. If it's a data, they might put a password and the secure, but since it's a log, they copy here and there everywhere. So now, end of the day, if someone get these logs, they can see everything, right? Why? That is a mistake software engineers does. Other thing is, if you not control this, let's say we are running a business, okay, and like let's say he's a developer, okay. So we are running a very sensitive business with we have so many competitors. He's a developer. So he knows when he done with the system development, he cannot access to the data because developers don't have access to production data. We don't give production data access to developers, right? So why developers don't get the production data access? Some people get, APS team get, application maintenance team getting, right? All the it's not the SRA, frontier maintenance team get the access to the production data. They can query database, but we don't give access to developers. Why? Anyone can think of why? Because technically, software engineers are very more capable than the supporting team. But why we give the access to support team but not to the software engineers? Any logical reason to do that? People asking this question from me when I'm saying no, you don't. I cannot give access to you. They're asking, okay, why? Why then those team has access? Here's the problem. When SRE team has access to the database data, they don't know meaning out of the data. Okay, so they were trained, if something happens, go to this table, fix this record. If something happened, go to this table and fix this report. But software engineers, they have access to the code base. Also, they know exactly where this data goes. What are the master table, what are the detail tables, what are the mapping tables. If you want to manipulate the data, they know exactly where to manipulate. Right? You can manipulate master data, you can manipulate the detailed data, and you can go to the mapping data. If you want to remove something, if you need to remove some whereabouts, they know exactly what tables you to be removed. And finally, they can go and they know where the audit trail hits and everything. So they know, they have in detail. That is why we don't give access to software engineers in the production. It is not about their capability or something. They are over capable to handle the production. That is why we don't give it. So now he knows, okay, I'm not going to get the access to production data. Right? So what he can do is, he can put sensitive data information into the logs. Right? So usually in the system, in the production system, developers even don't have access to production logs. Right? We give it, since we are in a rolling out stage, they don't have access to even production logs. If they need the production logs, they need to give like this, I need these logs from SRE team or a APS team, so then only they give the logs. Right? And also they can give a query, run this query in the production and export this data. So then this data go to the Jira or somewhere of a ticket. So there's a traceability. He got this data. Right? So that's how it works. So that is the other thing. If you do these logs in the wrong way, so this data is secured, but when it comes to the logs, these are files, flat files. Those we are not putting much security on that. Now the problem is how we can do it right, because we need the logs, but same time we need to make sure these logs doesn't add additional vulnerability or it's not doing some wrong thing to the system, or it does not contribute to the data leakage. Right? So logs are designed in a way to work with the log level. Right? So we have a log level called trace, and then we have a log level called debug, and then we have an info, then we have a warn, and then we have an error. Right? Some logging framework suppose something called fatal, but that is not common. Okay? So you have trace, debug, info, warn, error, and a fatal. Fatal is kind of optional. It's not always there, right? So here is how this works, right? So I'm going to erase this part to show you. So let's say in your code, you have a method A, right? And you have a method B. Right? So inside method A, we call method B. Okay? So now, for some reason, you need to tell your whereabouts. Where have you been? Where are you going? Where are you now? At what time you came here? And so and so. Right? So if you want to do that, you are using a trace logs to tell whereabouts. Right? Where have you been? Right? Arrive to this method executed, arrive to method this time, leaving method this time, so and so. Okay? So that is where trace logs comes. Debug logs, you put if you need to print any data. Okay? Sometimes let's say invoice number created along with this value. Invoice number 1234, value is 10,000. Customer is someone, something like that. If you need to print any data, output any data, then you use the debug log. Okay? Debug log or below, which is the trace log, should be the only logging level which you print the data. Okay? Info log is to give some information. Response dispatched. It can be a trace log too, right? But if you need some information which is you frequently need, especially these logs in the info logs, can sometime go into this side or this side. For example, if connection was if the connection disconnected from the broker or a messaging queue or somewhere, you can put that as an info log. But more likely it need be a warning log if it is a threat to the system. If it is something okay, fine. Let's say you have a so this is like somewhere, let's say you having 100 users on the system in a given time is kind of a significant, it's a milestone. When that happens, you can log 100 users reached, something like, it's information. Okay? Warn log is this where you need to, it's continuable, you can move forward, it is not a stopper, but stopping with a warning. Okay? For example, we are checking for some property, right? So if oath equal true, right? Let's say false. We put a warn saying authentication has been disabled, but you continue it, right? For example, in our case, in Ironhide, we can, in the non-production environments, we can set the token validation disable. We can do it with the property. Especially in dev environment, we can do it. Okay? So when we do that, if the token verification is disabled, every request comes, it's for a warning log. Token verification disabled. Or sometime some value go negative. Right? For example, inventory technically cannot go negative. There is no negative inventories. Okay? Technically. So now let's say you are running a shop floor or a let's say cashier post system, point of sale system in a supermarket, right? So now someone come with this phone, right? So when you are trying to, I know this phone is not selling in the supermarket, just hypothetical. There is a phone shop, right? So I'm going to sell this, right? When you go to system, quantity is 0. So you tell customer, sorry, we don't have a stock. But he says, hey, we have it. No, sir, you don't have a stock in the system. But He has it or something in hand, but we have to sell it now, right? This thing happen usually before it into the system, it come to the shop floor. There are practical situation happens, okay? Because usually what happens is from the stores, they transfer to the shop floor. Before we do that, they put the entry in the system, but physically someone moved it. So now customer come and pick it. Now when that happen, when we sell it, stock goes zero. Sorry, minus, right? That is a warning situation. We can put a warning log. Stock going beyond zero, something like that. That's a warning log. Error logs mean something happened. So if you have a fatal, what error means? Some error happens, but we can continue. Fatal mean error happens as stopper. But when you don't have the fatal, usually we use the error for both. So some error happens, we log the error. If we continue, we are saying we are continuing. Error log saying cannot find the file to write in the location. Info log saying file has been created, new file has been created, and continue, and you go, right? So technically errors, we are going to learn this in exception handling session. Technically speaking, errors are unrecoverable. Exceptions are recoverable. But there is no exception type logging. So exceptions also falling under this one, right? Exception plus errors, right? But engineering practice, exceptions are recoverable, so we have to handle it. We have to catch it. But errors, we cannot handle, we cannot recover, so we don't catch it, right? We never catch errors, we only catch exceptions, right? So, but in the log levels, we only have errors, that is something like exception, so that's how it goes. Now, I told you, you print the data on the debug level log. And also I told you before, printing the data on the logs is bad. Now what we do is, when we go to the production, we set a log level, okay? Most of stable production system, we only have these two on the prod. If the production system is stable, we only give warn and the error logs to the production. We don't give any other logs, right? When the production is not stable, sometimes we go in the below levels. Now, where we put the data? Which log level we put the data? Debug. So what we do is, when we go to the production, we log this point onwards. So on the production, you don't see that. So we log mean we don't change the code, right? We configure the login mechanism. You only should export the logs which is above the debug, right? We call drop filters. We drop these logs, okay? So now that is a one way, right? One way is, one system is drop the logs, right? So we are going to in the like in a couple of minutes later, we are going to learn about log management. So there you will see something called log shipping. We don't ship these logs, right? That's a one way to handle it. Second way is, you set the log level in the application itself. You set the log level in the application. But when you do that, what happens is, though there is a code to say log.debug, application doesn't execute that code. Why? Because your log level says info. If it is JavaScript, you can use something like a Pinot. If it is a Java, you can use a log4j, right? When you set the log level, you have a code, but it don't execute. So now, let's say there's a production issue, something going on in the production. You cannot reproduce this on a non-production environment, right? So what we can do is, we don't need to change the code. For that service, we set the log level to debug and produce a scenario. So then we will have the data. But we do that with the conscious saying, this will print the data to the logs. Okay? Understand? We are going to talk about this later on again, but since we are not discussed, I'm going to this kind of a touch base. So if you get any service, right, any backend service, there are 3 layers. One is controller, other one is service, other one is repository. Okay, there are 3 layers. We are going to learn these deep when we discuss the microservice and stuff, but to go to the next level, you need to have understanding of this. How does this work? Controller is responsible for exception handling and routing the request to the relevant service. There's only 2 responsibilities for the controller. Service is responsible to handle the business logic. Business logic code has to go in the service layer, right? Repository supposed to handle the data. Okay, these are the clear separation for these service layers. Okay, that does not mean if you write the business code on the controller, it will not work. It will work. You can write the repository even data code on the controller, it will work. But we don't do it. So this is the guideline and this is the separation. So now, when we logging, right? So we learn if you need to log the whereabouts and stuff, it's a trace. If you log the data, it's a debug. And if you need to give the warning, it's a warning. Okay? So we need to understand this one. Let's say we are logging an error. Some error happens here, repository layer. Okay? So now, you log the error on the repository layer. Right? The request comes here. Then it go to service call the repository, now error happens. Right? You log error. We logged here. So after logging, where it go back? To the service. Right? Now service perspective, is the request complete or not? No. What happened? There was error. So you're logging error. Right? And now it go to controller. Controller perspective, service success? No, error. You log the error. Now what happened? One error occurred. There are 3 logs entries. Just one error, 3 log entries. This is bad. Why? Because in the monitoring tools, we are monitoring number of errors in a given hour or something. So now this count as a 3 because they measure the errors through the error type, log type. Okay? So we are learning a practice in the exception handling call, either log or either throw, don't do the both. Right? So but here, when you need to understand, when you logging level is important. Right? You can log one of these as an error and log the rest as a warning. Right? So it depends on the coding guideline. Sometimes we guide to log the error where it happens and other places go as a warning. Or sometimes we log the error at the last point. So we have the complete exception stack trace. So we have the full information. Okay? It depends how you do it. But that is what you need to understand. You don't log the errors everywhere. Right? Okay. So now, before go to the next level, we need to understand this. There are multiple logging mechanism different architects use in their projects. Okay. So yesterday we had a tech talk. Then after that, someone came and discussed with me. It's a large organization, but what they do is the logging. The application logs into files. Right? They put the logs into files. Now the problem is, in a high scalable solution, if something happened to the node or a pod crash, then the log file will be missing. The log file is gone. Okay? And thing like this. So you are writing, this is your service, right? Employee service. So you are writing the log file. employee.log, right? So now there's a bug. Now what you need to do? You need to go to the log. So you open this. While you open and reading, there are so many other log entries comes because this is a production. There are so many other log entries would come there, right? So your action might lead to missing logs. Since your file is open, they may fail to write it. So the solution is sometimes people do is they put the log for every minute, separate log file, or every hour separate log file, or a size wise. Each file will be 1 MB. You write to this file, when the 1 MB fill, you go to this file and so log rotation. That's one technique that will save you. But still the problem is this, right? So when you debugging in a system, some systems we are hitting 10,000, 20,000 requests per second in the large scale solutions, right? So now when something goes wrong, when you open the log and check that, there are other 20,000 log entries there. So if someone do this mistake, 60,000 log entries, right? Now what the problem is, you have the logs, but it's really hard to debug. So what we do is, we do something called structured logging. Okay, structured logging. We don't do basic text-based logging, we do structured logging. The structured logging means every log entry follow a structure, right? Probably it's a JSON object. Application log something, say this happened, right? A request arrive to method A. When you give that text, your login framework log with some other metadata. Which service is, like for example, if you get this log object, it has a service, class, date time, probably user or correlation ID, and then the message, right? If it is a Kubernetes cluster, which pod caused this, right? Which service is this log belongs to? You have a bunch of information with the metadata. This is called structured logging, right? So I get it. It takes more space, right? I get it, because rather than adding a single line, now you are creating an object, right? Now this object, what we do is, let's say this is the pod, right? What I usually follow is log into the standard out. In any system, you have a standard error and a standard out, STD out and STD error. I usually prefer to log into the standard out. Okay, and then we have something like a fluent bit or a file bit. There are tools. What the tool can do is, they can collect the logs and ship somewhere, right? There is a stack called ELK, right? Elastic, Logstash and Kibana. What that does is, it collects the logs and ship to somewhere. Okay? Now we have a structured log. We have all the information, very structured way. We know what the message, what the time and everything. So Elastic can index nicely. Also we have a log level also. This service, just assume you are putting into a table. These are columns. Just assume you put in the table. Now, when you want to see the logs, you don't want to have opened the file, right? You say select asterisk from logs where service name equal employee service, right? Where employee service equal employee service and level is error. So you can query the logs without opening the file. But we don't enter these to database. What we do is, we take these logs and push to Elastic or somewhere. Before that, in our case, we send to S3, but we can send into local storage or anywhere, right? If you're using something like New Relic or Loki or not the Loki. There's other Neuralink kind of a tool. So if you are using that, we can ship to that one. But if not, you can ship to S3 or Elastic or wherever, some sort of destination. So what the FileBeat or a FluentBeat does, it collect the log. You can give a file. I will write the logs to this file and take it and put it to the S3. That is its job, right? You can tell, okay, when the file is reached 1 MB, push it, or when the file is reached to 1 minute, complete 1 minute, every minute you push it. You can set the rules. But end of the day, what happens is, if you take we don't know this yet, but in the Kubernetes type of architecture, we have a node. Node is a physical one, and physical mean it is the fixed one. So you have a pods. These are services, right? We put the logs here. Log can store in the node, and then from here you have a agent, FileBeat or a FileBeat agent that can push the logs to here. And Elastic can index it. If you want a Logstash, that is a Grok language, you can write the Grok filters. You can kind of transform the logs the way you want if these are not a structured log. If those are old system, they have a text-based log, right? And also some mechanism we are using like a Kafka.js, so those tools don't use the structured logs. So then we use this one, Grok filters to filter, and you can transform the logs and store in the Elastic. So now we give the Kibana. Now you can do the filtering, right? You can do the filtering. Filtering mean same thing what I told. Log service name, last hour, right? Employee service, last hour, errors. You can query. Those each tools has a different language. For example, Neuralink has something called NRQL, Neuralink query language. There is other tool I use, I don't remember its name now. And now we are doing a Loki. Right? Loki is similar as ELK, similar as not the Loki, it's a Loki. So this comes with a Grafana as an interface. Right? Loki is kind of a next version of, not the next version, but it's there are in some ways is better than the ELK. Okay. Now we see how the entire log management works. So you write the logs, we ship the logs, and then we transform the logs so you can go and query. Why we do that? Because otherwise getting the logs on the production, it's a long process, because you need to go to the server. There's a file, that file can be missing, and the file can corrupted. If the node crash, file is go somewhere. So many problems. Now with this proper log management, you don't face any of these problems. Based on what we discussed, what we do is we write the log, and then we transfer the log, okay, and we analyze the log, or we can say we index the logs, and we store the logs, and then later on we delete the logs. Retention period is depends system to system, right? But general practice is this, especially this is go for audit logs, which is very separate from this one. Right? Audit logs we don't keep with these logs. Audit logs is a very separate entity. We can discuss if you want later. Audit also those logs, we don't store the audit log with this one. If it is audit log, usual guideline, the practice is, let's say it's a finance solution, how long you can go to court for a financial fraud. If it is 10 years, you need to keep the logs for 10 years. Why? So you work on a system and you resign the company. 5 years later, company go to court against you. If it's allowed within 5 years, you go. Now, they ask, okay, prove the evidence, give the evidence. Now you cannot go and say, we delete the logs. You have to have the logs. That is why usually audit logs, in our case, we store up to 6 years or 15 years or something. But what we do is, when we store, first we store with the hot storage, like S3, and then we go for cold storage, like a Glacier. That's how we do. Because Glacier storage, very cheap, it just stay there. No one is bothering about it. If you want, there's a procedure to fetch it back. You can go to Glacier stores and request the files and so with those. But this is how we do it. Data are also same, archival also same. How long you want to keep the data, changing from business to business, but that is a kind of a guideline. If it is especially the finance type of a data, how long you can go to the court for this particular incident, and then it's better to retain the data for the logs or audit log for that period. That's not a rule. It's not a rule. It's a practice we follow, but that's not a rule. You can even delete within the 6 months or 1 month or next day. No one going to because if it's okay with you, it's not a problem. Now, this is the usual cycle. The logs usually we keep only up to like 3 years or so. We store the logs, then we delete it. But in most cases, general logs we don't need after 1 year. Why 1 year we keep? Okay, so let's say there's a business, order comes in January, right? It delivered on a September. It's a manufacturing order, something we are going to manufacture. The order comes in the January, we deliver in the September, right? And then if your log retention is a 6 month, by the time this delivery happen, the shipment happen, if they say, oh, okay, this is not what we ordered or something. Now you can go back and the log can see what really happened. Why? Logs are gone. Logs are gone in a 6 month. You don't have the logs. Right? Therefore, it depends on the business to business how long you need to keep the logs. So this is the in general theory how you should keep the log. But most of the time, most of the system does is you write the logs and you delete the logs. When I go for some architecture reviews, this is what I see. There is no proper log management solution on most of architectures people define. But it's very bad. It's not the write and delete. You have to go for full log cycles. When you put the logs, your messages, you always need to think like this. When I put a log message, I always picturing I am debugging this system. Sometimes log messages are there, error happens, cannot continue. That's it. Now, how we figure out what happened? It's not there. Error happens. Sometimes there are logs saying, cannot complete. Please refer the log for the detail. You are writing that on the log. So now where I do? Nothing. Right? So when you put the log entry, log message, always think I am debugging this system. Okay? I am debugging the system. We are going to discuss this in exception handling section. What we need to do is we need to propagate the causes to the top. We need to propagate causes to the top. Don't try to understand it now. We are going to discuss in exception handling section. The propagate to the top mean, in the top, when you log in the controller, it will say employee record cannot save, caused by employee service failure, caused by employee repository failure, caused by cannot reach to the database. So you know history of your issue. One log entry, one error log entry, it says what exactly happened. Don't just say fatal error. Error happens, cannot continue, unknown error. Because when you write in the code, if you are logging as unknown error, that is something unknown wrong with you. Why? Because based on the logic you are writing, you know why it's reaching there. At least give some context. At least tell in the log, these are things not happen. For example, it check multiple if conditions and it hits the default. It's not filtering anything. Don't just say unknown error, cannot continue. Just say these are set false, cannot continue. So when someone sees the log, he don't need to go back to the code. sometimes these errors comes, you need to go to debug this some very like unforeseen times. So for example, today around 4 a.m. suddenly I was woken up saying this. Right? So now I should be able to, based on the message, to tell what happened, what need to be checked. Right? So yesterday around close to midnight, DevOps called me and said, when we are trying to do this error comes. So instantly I knew what's wrong and how to fix. But if it says error happens, now I need to go to the code and see what is doing in this area, and so this is the possibilities, build so many hypotheses. Right? So reality, the real world, these issues come probably in the mid of the night, or while you are driving, or while you are just about to board to the airplane. Right? Something's happening. Let's say something happened, you are the only person you can solve it. Oh, I didn't understand it. You are about to board to the airplane. The practicality is you cannot stop the plane. Right? Once you board to the plane, you will unavailable for a few hours. Those are practical situations. So therefore, when you put something, make sure that message itself is sustainable for the next level. The last thing is this. So there is something called buzzword logging. Okay? Buzzword logging means you logging everything everywhere. Right? We discussed about the error. You log in the repository, you log in the service and use a controller. So now, if the log level is debug, it is not necessary you need to put the entire trace in a debug. Why? Debug is there for what? Print the data. If you need to see the whereabouts, you need to use the trace. You put the trace log is everywhere is fine. Right? So, for example, like sometime we are trying to give all the updates. So it arrived to method A, processing in the method A, about to leave the method A, leaving method A, come to method B, starting the process. So there is a top log saying arrive to method A. Then next log says starting the process. There is nothing between these two logs. Okay? No point. You need to understand these logs, it's cost money. Why? Storage. We are ingesting 10 terabytes of logs per month. How much is cost? It depends your solution and your vendor and how you do it, but no matter what, it's a cost. So stop doing this buzzword logging. You come to this method, I'm leaving this method. Just always see, is there a purpose of this log? What is the purpose this log is going to serve me? Because let's say you have a method starting here, right? These are variable defines. You define some variables. Can't go wrong. So you can put a log here if you want, but you adding the log here and log here doesn't make any sense, because this log doesn't do any, this one doesn't do anything for you. Understand? So don't do this buzzword logging. So as a summary, what the logging mean? It should help us, right? And we should help logging to help us. Why? Because if you do unstructured logging, that doesn't help. If you are logging to log files, that doesn't help. If you are logging the wrong log types, that doesn't help. If you are logging the wrong messages, that doesn't help. Right? If you do this buzzword logging, that doesn't help. Okay? So when you logging in your system, make sure you follow every single of these practices, right, from the day one. Don't do this. Sometime when we work on a system, what we do is, okay, you just do this time like temporarily, and then you go for the formal log later on. No, don't do it. From the day one, do the proper logging. What I usually do is, when I design the solutions, I design a logging library, extending a logging framework. Right? For example, here we have the rapid logger. So what the rapid logger does is, it takes your message and it injecting rest of the metadata to the log and it putting it. So there is no stress on the developer. And there's a one thing I forgot to mention on the logging. There is a something called logs. We use something called correlation ID, right? So logs should carry correlation ID if your system is a microservice system. Why? So let's say you have an employee service, you have a product service, you have a manufacturing service, and you have some sort of operation service. Okay? So now the request comes here, and from here it goes here, and from here it goes here, and it goes here and come back. Okay? And there can be other requests initially come here, and it will go here, and go here, and come back. Possible. Now, if there is an error or something happened on this service, you have no idea where this came from and where it's going next. This is called distributed tracing. There are frameworks for distributed tracing, but easiest way we can do is a correlation ID. What we do is the entry service, the initial service which take the request, adding a specific prefix to that. Service has a prefix. For example, product item service prefix is PIS. Right? So now what it does is it adding PIS to the correlation ID. So when we know the correlation ID, when we see the correlation ID, we know, okay, this request initiated on product item service. Right? Now I need to see what happened to this request. Now what you do? You take the correlation ID and query. Right? Select asterisk from logs where correlation ID is this. Now it tells, it initially hit the product item service. Now it is coming from this service, that service, so whatever. And we can exactly see where our request was propagated. That's called correlation ID. Right? Logging is, especially distributed logging, required the correlation IDs. Okay, any questions? No questions? Okay, probably tomorrow we can discuss the exception handling. I was thinking to do both today, but if I start now, that also will go for another hour because exception handling is a very deep topic that is not tied into any Java or a .NET or a Node.js or anything. It's common. There are practices on exception handling, and so let's not start today. Because it's more important than even this, no matter which language you use. So let's discuss this tomorrow.